Right now, as you read these words, something may be watching you, not from across the room, not from a satellite orbiting overhead, from somewhere far more distant and far more patient. For over 60 years, scientists have been scanning the skies for signals from extraterrestrial civilizations. They have found nothing: no radio transmissions, no laser pulses, no evidence that anyone else exists in a universe containing 2 trillion galaxies. This silence has a name: the Fermi paradox. And one of its most disturbing solutions suggests that the reason we haven't found alien life is because alien life found us first. They've been here all along, watching, studying, deliberately refusing to make contact because Earth is not a planet. It is a nature preserve, and humanity is the wildlife. This isn't science fiction invented for entertainment. This is a hypothesis proposed by serious scientists at serious institutions, published in peer-reviewed journals, debated at academic conferences. The zoo hypothesis, first formally articulated by MIT astronomer John Ball in 1973, suggests that advanced extraterrestrial civilizations have deliberately chosen to observe humanity from a distance without interfering, like zookeepers studying animals in a carefully controlled habitat. Like researchers watching an isolated tribe from hidden cameras in the jungle, like gods who see everything but choose to remain invisible. The implications are staggering. Every moment of human history may have been witnessed. Every war, every breakthrough, every act of love and cruelty. They watched the first humans leave Africa. They watched empires rise and fall. They watched us split the atom and walk on the moon. And they have never once revealed themselves, not because they don't exist. Because they choose to remain hidden, because we are the exhibit, and the exhibit is not supposed to know it is being watched. In the next 2 hours, we will explore why serious scientists consider this possibility. We will examine the evidence that something intelligent may be observing Earth, and we will confront the terrifying question of what might happen if the zookeepers finally decide to make contact. If you enjoy this journey, consider liking and subscribing. Now take a breath. We begin with the silence that started everything. The summer of 1950 was unremarkable in most ways. The Korean War had just begun. The first credit card was introduced. A gallon of gas cost 18 cents. But in a dining hall at Los Alamos National Laboratory, a conversation occurred that would haunt science for the next 75 years. Enrico Fermi was eating lunch with fellow physicists Edward Teller, Herbert York, and Emil Konopinski. The conversation drifted to recent UFO reports in the news, then to the possibility of faster-than-light travel, then to the likelihood that other civilizations existed somewhere in the galaxy. Fermi, a Nobel laureate known for his ability to make quick calculations about seemingly impossible questions, suddenly looked up from his meal and asked a simple question that nobody could answer. Where is everybody? The question seemed almost childish. But Fermi had done the math in his head, and the math didn't work. The Milky Way galaxy contains somewhere between 100 billion and 400 billion stars. It is approximately 13 billion years old. Even if intelligent civilizations are extraordinarily rare, even if only 1 in a million stars develops a planet with intelligent life, there should still be hundreds of thousands of civilizations in our galaxy alone. And our galaxy is just one of 2 trillion. The mathematics grow even more disturbing when you consider time. Human civilization has existed for perhaps 10,000 years. Industrial civilization for only 200. We went from the first powered flight to landing on the moon in 66 years. If even a single civilization in our galaxy developed space travel just 1 million years before us, a tiny fraction of galactic history, they would have had time to colonize the entire Milky Way. The calculations have been refined many times since that lunch in 1950. Even conservative estimates suggest that a civilization with spacecraft traveling at just 10% of light speed, well within the bounds of known physics, could colonize every habitable planet in the galaxy within a few million years. Add self-replicating probes to the equation, machines that can build copies of themselves from raw materials found on asteroids and moons, and the colonization time drops further. The galaxy should be teeming with evidence of intelligent activity. We should see megastructures blocking starlight. We should detect radio signals or laser communications. We should find artifacts on the moon or in the asteroid belt. We should have been visited, contacted, colonized, or destroyed long ago. Instead, we find nothing. Silence. A universe that appears completely empty despite every calculation suggesting it should be full. This is the Fermi paradox. And it has no satisfying solution. But here's where the mystery deepens into something far more unsettling. Scientists have proposed dozens of solutions to the Fermi paradox over the decades. Perhaps intelligent life is simply rarer than we assume. Perhaps civilizations inevitably destroy themselves before achieving interstellar travel. Perhaps the distances between stars are simply too vast to cross. Perhaps we are the first, the only, the lonely pioneers of consciousness in an otherwise dead cosmos. Each solution has problems. Each leaves questions unanswered. But one solution stands apart from the others because it doesn't assume that extraterrestrial intelligence is absent. It assumes extraterrestrial intelligence is present but deliberately hiding. John Ball was an astronomer at MIT's Haystack Observatory when he published a paper in the journal Icarus in 1973. The paper was titled The Zoo Hypothesis, and it proposed something that seemed almost absurd at first glance. What if the reason we haven't detected alien civilizations is because they don't want to be detected? What if Earth is essentially a cosmic nature preserve, set aside by advanced beings who have chosen to observe rather than interfere? Ball wasn't suggesting this as fact. He was proposing it as a logically consistent solution to the Fermi paradox. If extraterrestrial civilizations exist and are technologically advanced enough to travel between stars, they are certainly advanced enough to hide their presence from primitive species like us. A civilization that can cross interstellar distances can certainly avoid detection by creatures who only invented radio a century ago. The zoo hypothesis resolves the paradox by inverting our assumptions. We assume that if aliens existed, they would contact us. But why would they? What would they have to gain? We don't attempt to have diplomatic relations with chimpanzees. We don't send ambassadors to ant colonies. We observe them. We study them. We sometimes protect them. But we don't reveal ourselves as their cosmic supervisors because doing so would fundamentally alter their behavior. The same logic might apply to humanity. If advanced civilizations are watching Earth, contact might be forbidden precisely because it would disrupt the natural development of our species. We might be the subjects of the longest-running experiment in the universe, and the experimenters have no intention of contaminating their data. What they found next would prove even more disturbing about the conditions required for such a scenario. For the zoo hypothesis to work, several conditions must be met, and disturbingly, every one of those conditions appears plausible given what we know about the universe. First, there must be extraterrestrial intelligence. This seems increasingly likely as we discover more and more exoplanets in habitable zones around other stars. The Kepler Space Telescope alone identified over 2,000 confirmed planets before its retirement. Current estimates suggest there may be more planets than stars in our galaxy, with billions of those planets orbiting in the habitable zones of their parent stars. The ingredients for life appear to be everywhere. Second, that intelligence must be old. The universe is 13.8 billion years old. Earth formed only 4.5 billion years ago. There was time before our planet even existed for other civilizations to develop, mature, and potentially achieve technological capabilities we cannot imagine. If other intelligent species arose even 1% earlier in cosmic history, they would have a head start of over 100 million years. In that time, they could have mastered technologies that appear to us as indistinguishable from magic. Third, those civilizations must have survived. This is the most uncertain condition. Human civilization has existed for 10,000 years and has already developed weapons capable of destroying itself. Perhaps most civilizations don't survive long enough to achieve interstellar travel. But even if 99% of civilizations destroy themselves, the remaining 1% across billions of years and trillions of planets would still produce an enormous number of survivors. Fourth, those survivors must have coordinated. This is where the zoo hypothesis becomes particularly interesting. For the hypothesis to explain the complete silence we observe, not just one civilization, but essentially all advanced civilizations must agree to leave Earth alone. There must be something like a galactic consensus, a shared understanding that primitive species should not be contacted. This requirement seems implausible at first. How could beings spread across thousands of light years coordinate their behavior? How could they agree on anything? But consider how communication might work for civilizations millions of years more advanced than us. They might have communication networks spanning the galaxy. They might have artificial intelligences coordinating their activities. They might have reached similar conclusions independently, recognizing that non-interference produces better outcomes than contact. Ball called this possibility the Galactic Club hypothesis. Earth might be excluded from a community of spacefaring civilizations, not because they don't know we exist, but because we haven't yet qualified for membership. Like a primitive tribe that hasn't been contacted by the modern world, we might be protected rather than ignored, quarantined rather than forgotten. This discovery was only the beginning of understanding what such a scenario might mean for humanity. The zoo hypothesis gained little traction when Ball first proposed it. The idea seemed too speculative, too unfalsifiable, too close to science fiction for serious scientific discourse. But in the decades since, the hypothesis has attracted renewed attention for a disturbing reason. We keep failing to find anyone else. The search for extraterrestrial intelligence, known as SETI, has been scanning the skies since 1960. The first project, conducted by Frank Drake at the National Radio Astronomy Observatory, pointed a radio telescope at two nearby sun-like stars and listened for signals. He found nothing. 65 years later, despite exponentially more powerful equipment and searches covering millions of stars, SETI has still found nothing. No artificial radio signals, no laser pulses, no evidence of megastructures or Dyson spheres blocking starlight, no signs of industrial pollution in the atmospheres of exoplanets, no probes in our solar system, no artifacts on the Moon or Mars. Nothing. The Breakthrough Listen initiative, launched in 2015 with $100 million in funding, represents the most comprehensive search for extraterrestrial intelligence ever conducted. It uses some of the world's most powerful radio telescopes to survey nearby stars, nearby galaxies, and the entire plane of the Milky Way. So far, it has found nothing that cannot be explained by natural phenomena or human interference. Each negative result makes the puzzle more acute. If intelligent life is common, where is everybody? If intelligent life is rare, why did it arise on Earth? If intelligent life exists but remains hidden, why would it hide? The zoo hypothesis offers an answer that becomes more compelling as alternatives are eliminated. We haven't found anyone because someone doesn't want to be found. The silence isn't evidence of absence, it's evidence of intention. But here's where the mystery deepens into the specific mechanisms by which such observation might occur. If Earth is being watched, how would the watching happen? What technologies might allow an advanced civilization to observe us without being detected? The answers are less fantastical than you might expect. In fact, we ourselves are already developing some of the necessary capabilities. Consider what humanity has achieved in just the last few decades. We have placed telescopes in space that can image exoplanets around distant stars. We have developed cameras so sensitive they can detect the light from a single photon. We have built networks of satellites that can monitor every square meter of Earth's surface continuously. We have created artificial intelligence systems that can analyze vast amounts of data and identify patterns invisible to human observers. Now extrapolate these capabilities forward by 1,000,000 years. Consider what technologies might be possible for a civilization that has had 1,000,000 years longer than us to develop science and engineering. The gap between their capabilities and ours might be comparable to the gap between our capabilities and those of single-celled organisms. Such a civilization could observe Earth from distances that make detection impossible. A telescope positioned in the outer solar system, perhaps hidden among the trillions of objects in the Oort cloud, could monitor Earth in exquisite detail without ever being noticed. Probes smaller than dust particles could be distributed throughout the solar system, invisible to our instruments, continuously transmitting data about our activities. They might not even need physical presence in our solar system. A civilization capable of gravitational lensing, using the mass of the sun itself to focus light from Earth, could observe our planet from light years away with resolution sharp enough to read a book. We already know gravitational lensing works. We use it to observe distant galaxies. An advanced civilization might use it to observe us. The electromagnetic spectrum offers even more possibilities. We transmit vast amounts of information in radio waves, television signals, cellular communications, and radar. Every day, electromagnetic signatures of human activity radiate outward into space at the speed of light. An advanced civilization within 100 light years could be receiving broadcasts of human entertainment, news, and scientific data. They might know more about human civilization from our leaked transmissions than we know about ourselves. And these are just the possibilities we can imagine based on our current understanding of physics. A civilization millions of years more advanced might use technologies operating on principles we haven't discovered yet. They might manipulate dimensions we don't even know exist. They might observe us through mechanisms that our science cannot conceive. The notion that we could detect such observers is almost certainly naive. We are searching for signals using technology we invented a century ago. We are like indigenous peoples scanning the forest for rival tribes, unaware that satellites are photographing every tree from orbit. Our instruments might be fundamentally incapable of detecting the methods by which we are observed. What they found next would prove even more disturbing about historical events that might support this hypothesis. Throughout human history, there have been events and observations that resist conventional explanation. Most of these can be attributed to natural phenomena, misperception, or fraud, but some remain genuinely puzzling, and the zoo hypothesis offers an interpretive framework that puts them in a new light. Consider the UFO phenomenon. For decades, reports of unidentified flying objects were dismissed by serious scientists as misidentification, hoaxes, or delusions. But in recent years, that attitude has shifted. The United States government has officially acknowledged that military pilots have encountered objects displaying flight characteristics beyond any known human technology. The Pentagon has released videos showing aircraft performing maneuvers that would destroy any vehicle built with current engineering. Congressional hearings have featured testimony from credible witnesses describing encounters with craft that appeared to defy physics. None of this proves that extraterrestrial visitors are observing Earth. There are prosaic explanations for some incidents. Others might involve classified human technology, but the pattern of encounters fits surprisingly well with the zoo hypothesis. If an advanced civilization were observing us, we might expect occasional glimpses of their technology, quick appearances followed by rapid disappearance. Objects that demonstrate capabilities beyond our understanding but never make sustained contact. Observers who want to watch without being fully seen. The zoo hypothesis doesn't require that all UFO reports be genuine. It only requires that some small percentage might represent actual observations of non-human technology. Given the thousands of reports from credible witnesses over the decades, even a tiny fraction being genuine would have profound implications. Historical accounts of unexplained phenomena extend back far before the modern UFO era. Ancient texts from civilizations around the world describe encounters with beings from the sky. Some of these descriptions can be understood as religious or mythological narratives, attempts to explain natural phenomena using the cultural frameworks available at the time. But others are strikingly detailed and technological in character. The Vimanas described in ancient Indian texts were flying vehicles with specific technical characteristics. Egyptian hieroglyphs depict objects that some researchers interpret as aircraft or helicopters. Medieval paintings occasionally contain objects in the sky that appear out of place for their historical context. These observations don't constitute proof of anything, but they form a pattern that at least raises questions about whether something has been observing humanity for a very long time. Perhaps the most intriguing suggestion comes from an unexpected source. In 2017, astronomers detected an object passing through our solar system that had clearly originated from interstellar space. They named it Oumuamua, a Hawaiian word meaning scout or messenger. The object behaved strangely. Its shape appeared to be highly elongated, unlike any asteroid or comet ever observed. It accelerated as it left the solar system in ways that could not be fully explained by outgassing or solar radiation pressure. Avi Loeb, chair of Harvard's astronomy department at the time, proposed that Oumuamua might be an artifact of extraterrestrial technology, perhaps a solar sail or a probe sent to observe our solar system. His suggestion was controversial and rejected by many astronomers, but it came from one of the most credentialed scientists in the field, and it illustrated how the zoo hypothesis intersects with actual observations. If observers have been watching Earth, we might expect them to occasionally send probes or vehicles that become briefly visible before disappearing. We might expect anomalous objects in our solar system that don't fit natural categories. We might expect a long historical record of unexplained aerial phenomena. All of these exist. None of them proves the zoo hypothesis, but all of them are consistent with it. But here's where the mystery deepens into why an advanced civilization might choose to observe rather than contact. The question of motivation is central to the zoo hypothesis. Even if advanced civilizations exist, even if they are capable of observing Earth, why would they choose to do so? What would they gain from watching humanity without making contact? One possibility is scientific curiosity. Humanity has spent enormous resources studying animal behavior, from Jane Goodall's decades with chimpanzees to cameras monitoring remote ecosystems. We study other species because we want to understand life, intelligence, and behavior in contexts different from our own. An advanced civilization might have the same motivations. They might study primitive species across thousands of planets, building a comprehensive database of how intelligence develops and civilizations evolve. Earth might be particularly interesting because of its biodiversity. Our planet hosts an extraordinary variety of life, from deep-sea organisms to flying insects to intelligent primates. The sheer complexity of Earth's biosphere might make it a valuable subject for study. We might be one observation among thousands, a single data point in an ongoing galactic research project. Another possibility is protection. Many scientists and philosophers have argued that contact with a vastly superior civilization would be devastating for humanity, not because of hostile intent, but because of the psychological and cultural shock. Imagine the reaction if incontrovertible proof of advanced aliens appeared tomorrow. Religious frameworks would be challenged. Scientific understanding would seem suddenly primitive. Humanity's sense of its own importance in the cosmos would be shattered. An advanced civilization might recognize these dangers and choose to avoid contact for our own good. They might have observed other species react badly to first contact and developed a policy of non-interference as a result. They might be waiting for us to mature, to develop the psychological and social resilience necessary to handle the truth. There might also be practical reasons related to our potential threat level. A species capable of developing nuclear weapons in less than a century of industrial development might be considered dangerous. Contact might be withheld until we demonstrate that we can manage our own technology without destroying ourselves. We might be quarantined not to protect us, but to protect the rest of the galaxy from a potentially destructive species. The Fermi paradox suggests that many civilizations might destroy themselves before achieving interstellar travel. If this is true, advanced civilizations might have learned to avoid contact with potentially self-destructive species. Why invest resources in communication with a species that has a high probability of extinction within a few centuries? Better to wait and see if we survive. This raises an uncomfortable possibility. The observers might be waiting for us to pass a test we don't know we're taking. A test that determines whether we join the galactic community or remain forever isolated in our cosmic zoo. What they found next would prove even more disturbing about the ethical implications of the zoo hypothesis. If Earth is a zoo and humanity is the exhibit, profound ethical questions arise. Are we subjects of a vast experiment? Are our lives being monitored for scientific purposes without our consent? Does our apparent freedom of choice exist only within boundaries set by unseen observers? These questions mirror debates in human ethics about animal experimentation and nature preservation. We create zoos and nature reserves with good intentions, seeking to protect species and advance scientific understanding. But the animals inside don't understand their situation. They don't know they are being watched. They don't consent to their captivity, however benevolent. From the perspective of the animal, there might be no meaningful difference between a zoo and prison. Both involve confinement and observation by beings whose purposes are incomprehensible. An elephant in a sanctuary is still an elephant whose movements are constrained by fences it didn't build and decisions it didn't make. If humanity exists in a similar situation, our entire conception of freedom might be illusory. We might have free will only in the sense that a fish in an aquarium has free will. We can swim anywhere we want within the tank. We can form social structures and pursue goals of our own choosing. But the boundaries of our existence are set by others. This possibility becomes more troubling when we consider the specifics of human history. If observers have been watching for thousands of years, they have witnessed enormous suffering. They have watched wars kill millions. They have watched famines and plagues devastate populations. They have watched genocide and slavery and cruelty on scales that shock the conscience. And they did nothing. If the zoo hypothesis is correct, beings with the power to prevent human suffering chose not to intervene. They watched the Holocaust and did not act. They watched children die of preventable diseases and did not share their medical knowledge. They observed every atrocity in human history and maintained their policy of non-interference. How would we judge such beings? By human ethical standards, failure to prevent suffering when you have the power to do so is itself a moral failure. We condemn those who stand by while others suffer. We hold them accountable for their inaction. But perhaps the observers operate under different ethical frameworks. Perhaps they believe that interference would cause greater harm than non-interference. Perhaps they have watched countless civilizations and learned that intervention produces worse outcomes than letting species develop on their own. Perhaps they see something in the long arc of history that makes our suffering seem temporary and ultimately purposeful. Or perhaps they simply don't care. Perhaps they are as indifferent to human suffering as we are indifferent to the suffering of insects. Perhaps the gap between their consciousness and ours is so vast that our pain doesn't register as morally significant. This is the most disturbing implication of the zoo hypothesis. It forces us to confront the possibility that beings exist who are to us as we are to animals. Beings for whom our greatest achievements are as insignificant as an anthill's expansion. Beings for whom our most profound suffering is as meaningless as the death of a single bacterium. We might be cosmic pets at best, cosmic specimens at worst, and the zookeepers have their own purposes that have nothing to do with our well-being. The first section of our exploration ends here. We have traced the Fermi paradox and the silence that gives it weight. We have examined the zoo hypothesis proposed by John Ball and the conditions that would make such a scenario possible. We have considered what technologies might allow observation without detection. We have explored historical events that might be consistent with ongoing observation. We have confronted the motivations that might drive such behavior and the ethical implications of living in a cosmic zoo. In the next section, we will go deeper. We will examine related hypotheses that build on the zoo concept. We will explore the simulation argument and its unsettling connection to the idea that our reality is designed and monitored. We will consider what happens when the zookeepers decide to make contact, and we will ask whether there is any way to test these ideas, any evidence that might confirm or refute the possibility that something is watching. The silence of the cosmos continues. The universe offers no answers, and somewhere out there, perhaps closer than we imagine, something may be waiting to see what we do next. The zoo hypothesis does not exist in isolation. It belongs to a family of ideas that attempt to explain the Fermi paradox through the assumption that advanced intelligences are present but deliberately hidden. Each variation adds new dimensions to the possibility that humanity exists under observation, watched by beings whose purposes we cannot fathom. In 1987, astronomer Guillermo Lemarchand and colleagues proposed what they called the planetary park hypothesis. This refinement of Ball's original idea suggested that Earth might be more than a passive exhibit. It might be an actively managed preserve, maintained by advanced civilizations the way humans maintain national parks and wildlife sanctuaries. The observers would not merely watch from a distance. They would actively intervene to ensure the preservation continues, protecting Earth from threats that might destroy the experiment before it reaches completion. Consider what such management might involve. Advanced civilizations might deflect asteroids that would otherwise impact Earth. They might intervene in ways too subtle for us to detect when existential threats emerge. They might have been shaping conditions on our planet for millions or billions of years, ensuring that the experiment of life on Earth continues to produce interesting results. This is speculative, of course, but it offers an explanation for something that has puzzled scientists for decades. Earth has experienced 5 mass extinction events over the past 500 million years. Each one wiped out the majority of species then living, and yet life recovered every time. New species arose to fill the empty niches. Evolution continued its experiment in complexity and intelligence. The most recent mass extinction, the one that killed the dinosaurs 66 million years ago, cleared the way for mammals to dominate the planet. If that asteroid had missed Earth, dinosaurs might still rule, mammals might never have evolved intelligence, humanity might never have existed. Was this coincidence, or was it managed? The question sounds absurd until you consider the alternative. If advanced civilizations exist and have been observing Earth for millions of years, they would certainly have the capability to steer asteroids. They could nudge objects in the asteroid belt, adjust trajectories over centuries or millennia, ensure that impacts occur when and where they want them to occur. The asteroid that killed the dinosaurs might have been deliberately aimed. The extinction might have been engineered to produce a new evolutionary direction. The rise of mammals, primates, and eventually humans might have been the intended outcome of cosmic intervention. This is not evidence. This is speculation. But it is speculation that follows logically from the premises of the zoo hypothesis. If observers exist, if they have been present for millions of years, if they have technology far beyond our understanding, then everything about Earth's history might have been shaped by their decisions. What they found next would prove even more disturbing about how this management might extend to human history itself. The planetary park hypothesis raises an uncomfortable question. If observers have been managing Earth's development for millions of years, would they stop when humans appeared? Or would their management extend to shaping human civilization as well? Consider the strange contingencies of human history. How many times has civilization teetered on the brink of destruction, only to survive through improbable circumstances? How many times have critical discoveries been made by individuals who were almost not born, almost died young, almost pursued different paths? How many times have catastrophic wars been avoided by narrow margins that seem almost miraculous in retrospect? The Cuban Missile Crisis of 1962 brought humanity to the edge of nuclear annihilation. For 13 days, the United States and Soviet Union confronted each other with enough weapons to destroy civilization multiple times over. At several points during the crisis, nuclear war was avoided by the decisions of individual people, decisions that could easily have gone the other way. Vasily Arkhipov was a Soviet naval officer aboard a nuclear-armed submarine during the crisis. His submarine was being depth-charged by American destroyers. The captain and political officer wanted to launch a nuclear torpedo. Only Arkhipov's refusal prevented the attack that would have started World War III. One man's decision, made under extreme pressure in a submarine with no communication to the outside world, may have saved human civilization. Was this coincidence? Was it luck? Or was it intervention? The question applies to countless moments in history. The survival of Winston Churchill, who was struck by a car in New York in 1931 and narrowly avoided death. The failure of multiple assassination attempts against critical historical figures. The timing of technological discoveries that arrived just when they were needed. The weather that changed the course of battles. The accidents that prevented catastrophes. Individually, each of these events can be explained by chance. Collectively, they form a pattern that at least raises questions. If observers were managing human history, steering us away from extinction, how would we know? The interventions would be subtle enough to seem like coincidence. The management would be invisible to those being managed. This possibility takes the zoo hypothesis into territory that feels almost theological. It suggests a form of providence operating behind the scenes of history. Not gods in the traditional sense, but beings with godlike powers whose purposes include the preservation and development of humanity. But here's where the mystery deepens into the simulation argument and its disturbing connection to the zoo hypothesis. In 2003, philosopher Nick Bostrom published a paper that sent shockwaves through academic philosophy and eventually into popular culture. The paper, titled "Are You Living in a Computer Simulation?", presented an argument so logically rigorous that it has resisted refutation for over 2 decades. Bostrom's argument proceeds from 3 propositions, exactly one of which must be true. Either civilizations almost always destroy themselves before developing the capability to run detailed simulations of conscious beings, or civilizations capable of running such simulations choose not to do so, or we are almost certainly living in a simulation right now. The logic is straightforward. If civilizations survive and choose to run simulations, they would likely run vast numbers of them. A single advanced civilization might create billions of simulated universes, each containing billions of simulated conscious beings. The number of simulated beings would vastly outnumber the real beings. Therefore, any randomly selected conscious being is almost certainly simulated rather than real. The simulation argument is not the same as the zoo hypothesis, but the two ideas share a profound connection. Both suggest that our reality is observed and perhaps managed by beings operating at a higher level of existence. Both suggest that the true nature of our situation is hidden from us. Both suggest that what we perceive as reality might be a constructed environment rather than fundamental existence. If we live in a simulation, the simulators are the ultimate zookeepers. They created the zoo. They defined its rules. They observe everything that happens within it because they have access to the underlying code. Nothing occurs without their knowledge. Nothing exists except what they allow to exist. The simulation hypothesis actually strengthens the zoo hypothesis in an unexpected way. One of the weaknesses of the zoo hypothesis is explaining how multiple independent civilizations could coordinate to leave Earth alone. Why would everyone agree to the same policy? But if we live in a simulation, there might be only one civilization that matters, the one running the simulation. The apparent coordination is trivial because there is only one observer, one designer, one entity making all the decisions. The simulation argument has attracted serious attention from scientists and technologists. Elon Musk has stated publicly that he believes the odds we are living in base reality are billions to 1 against. Neil deGrasse Tyson has suggested the probability of simulation is better than 50%. These are not fringe figures making wild claims. They are accomplished individuals taking the argument seriously because they cannot find logical flaws in it. But the simulation argument also creates new puzzles. If we are simulated, what is the purpose of the simulation? Are we entertainment, research, art? Are we meaningful to our creators or incidental byproducts of some larger computation? What they found next would prove even more disturbing about what the purpose of such observation might actually be. The question of purpose haunts both the zoo hypothesis and the simulation argument. Why would advanced beings expend resources observing primitive species? Why would simulators create vast universes containing conscious beings who suffer and struggle and die? The answers range from benign to horrifying. One possibility is that we are part of a research project aimed at understanding the development of intelligence and civilization. Just as human scientists study animal cognition, alien observers might study the emergence of consciousness across the galaxy. We might be one of millions of planets under observation, contributing data to a comprehensive model of how minds arise from matter. This possibility has a somewhat comforting aspect. Research subjects are usually protected because their value depends on their continued existence. If we are valuable data, our observers have an incentive to ensure we survive. They might intervene to prevent extinction while otherwise allowing natural development. We might be protected without knowing it. Another possibility is that we are entertainment. Advanced civilizations with effectively unlimited resources might create or observe primitive worlds the way humans watch reality television. Our struggles, our triumphs, our dramatic conflicts might be fascinating to beings who have solved all their own practical problems and need new sources of novelty. This possibility is less comforting. Entertainment value doesn't require that the subjects thrive. Drama often emerges from conflict and suffering. If we are entertainment, our observers might have no particular interest in our well-being. They might even prefer that we face challenges and difficulties because these produce more interesting viewing. A third possibility is that we are an experiment in a more active sense. Our observers might be testing hypotheses about how civilizations develop under different conditions. They might be manipulating variables, introducing stimuli, observing responses. The entire arc of human history might be a controlled experiment designed to answer questions we cannot even formulate. If this is the case, some of the strangest events in human history might be deliberate interventions. New technologies might have been introduced or suppressed. Historical figures might have been supported or removed. Wars might have been started or prevented based on experimental design rather than natural causation. A fourth possibility is that we are being evaluated. The observers might be deciding whether humanity qualifies for something, perhaps membership in a galactic community, perhaps access to advanced technology, perhaps survival itself. Our choices, our values, Our behavior as a species might be determining our future in ways we cannot perceive. This possibility suggests that the zoo is actually a test, a prolonged evaluation period during which humanity must demonstrate its worthiness. The criteria for success might be technological achievement or ethical development or some combination of factors we haven't identified. We might be close to graduation or close to failure, and we would have no way of knowing which. A fifth possibility is the most disturbing of all. We might serve purposes that we cannot comprehend because our minds are not capable of comprehending them. Just as an ant cannot understand why humans build ant farms, we might be fundamentally unable to understand why our observers observe us. Their purposes might require concepts that human cognition cannot represent. This possibility represents a kind of cosmic horror, the recognition that we might exist for reasons that would remain forever beyond our understanding. We might ask why indefinitely and never receive an answer that makes sense to us. The gap between observer and observed might be so vast that communication of purpose is impossible even in principle. But here's where the mystery deepens into the question of what might trigger the end of observation. Every zoo visitor eventually leaves. Every experiment eventually ends. Every observation eventually produces enough data to answer the questions being asked. If Earth is a zoo or a nature preserve or a simulation or an experiment, what might cause the observation period to end? The zoo hypothesis, in its various forms, suggests that non-interference is contingent rather than absolute. The observers are choosing not to make contact, which means they could choose differently. Something might change their minds. Some trigger might cause them to reveal themselves, intervene directly, or end the observation entirely. One possibility is that we might trigger contact by reaching a certain technological threshold. Perhaps the observers wait for species to develop interstellar travel, demonstrating that they have achieved capabilities worthy of the galactic community. Our current efforts to reach the Moon and Mars might be significant not for their practical outcomes, but for what they signal to watchers. We might be approaching a moment when our technological adolescence ends and our cosmic adulthood begins. Another possibility is that contact is triggered by our detecting the observers. Many formulations of the zoo hypothesis suggest that the rule is non-interference until the observed species discovers the observation. Like the Prime Directive in Star Trek, the policy might prohibit contact with species that don't know they're being watched, but allow contact once the secret is out. This creates an interesting dynamic. If the observers reveal themselves when we detect them, then searching for the observers is not futile. SETI might succeed not by finding alien civilizations that are openly broadcasting, but by finding evidence of observation that triggers acknowledgement. The search for extraterrestrial intelligence might be a test of our intelligence, with success rewarded by contact. A third possibility is that contact is triggered by crisis. Perhaps the observers intervene only when the observed species faces extinction from external threats or self-destruction. They might be waiting to see if we can solve problems like nuclear proliferation and climate change on our own, ready to step in only if we demonstrably cannot. This would explain the apparent increase in UFO sightings during periods of nuclear tension. If observers are monitoring our capability for self-destruction, they might pay closer attention when that capability is most likely to be used. The appearance of unexplained craft near nuclear facilities and military installations would be consistent with observers evaluating our existential risk. A fourth possibility is that contact is triggered by our moral development. Perhaps technological capability is necessary but not sufficient for joining the galactic community. Perhaps we must also demonstrate ethical maturity, the capacity to coexist peacefully with each other and potentially with alien species. Our ongoing struggles with war, inequality, and environmental destruction might be disqualifying factors, failures that keep us in quarantine until we do better. This possibility has troubling implications for the timeline of potential contact. Human moral progress is slow and uncertain. We might never achieve the ethical standards required for acceptance. We might remain in our cosmic zoo indefinitely, perpetual primitives who cannot learn to behave themselves. A fifth possibility is that the observation has a fixed duration regardless of our development. Perhaps we are being observed for a predetermined period, after which some decision will be made about our fate. Perhaps that period is ending soon, or has already ended, or will not end for millions of years. We would have no way of knowing. What they found next would prove even more disturbing about historical figures who may have suspected the truth. Throughout history, certain individuals have articulated ideas that resonate with the zoo hypothesis, describing humanity's situation in terms that suggest observation from beyond. Some of these were religious figures whose insights might be reinterpreted through the lens of alien observation. Others were scientists and philosophers who explicitly considered the possibility that we are not alone and not unobserved. The ancient Greek philosopher Epicurus, writing in the 3rd century BCE, proposed that the universe contained infinite worlds, some inhabited by beings unlike humans. He suggested that the gods, if they existed, might be indifferent to human affairs, observing without intervening. His philosophy anticipated key elements of the zoo hypothesis by over 2,000 years. Giordano Bruno, burned at the stake in 1600 for heresy, argued that the universe was infinite and contained countless inhabited worlds. He proposed that beings on those worlds might be more advanced than humans, closer to the divine. His vision of cosmic pluralism implied that humanity might be a minor species in a populated universe, observed from above by superior intellects. In the 20th century, scientists began explicitly formulating ideas that would become the zoo hypothesis. Konstantin Tsiolkovsky, the Russian rocket pioneer, proposed in the 1930s that advanced civilizations might quarantine primitive species to protect them from premature contact. He imagined a cosmic ethics in which more developed beings take responsibility for less developed ones. Carl Sagan, perhaps the most famous astronomer of the 20th century, repeatedly addressed the possibility that Earth might be under observation. While publicly skeptical of UFO reports, Sagan acknowledged that the absence of evidence for alien contact was genuinely puzzling, and that deliberate hiding was one possible explanation. He was instrumental in developing the Drake equation, which attempted to quantify the probability of intelligent life in the galaxy, and he recognized that the equation's results implied a universe far more populated than our observations suggested. More recently, scientists at prestigious institutions have published papers exploring variations of the zoo hypothesis with increasing rigor. The idea has moved from fringe speculation to legitimate academic inquiry, discussed in journals like the International Journal of Astrobiology and Acta Astronautica. Stephen Hawking, before his death in 2018, warned that contact with advanced civilizations might be dangerous for humanity. He compared the potential encounter to the arrival of Europeans in the Americas, devastating for the indigenous populations. His warning implied that alien civilizations exist and that their intentions toward humanity might not be benevolent. If Hawking suspected we might be observed, he also suspected the observers might not have our best interests at heart. But here's where the mystery deepens into specific evidence that might support the hypothesis. The zoo hypothesis is notoriously difficult to test. By definition, the observers are hiding, which means any evidence of their presence would be subtle and ambiguous. But absence of proof is not proof of absence, and certain observations at least create room for the hypothesis to be true. The wow signal remains the most tantalizing hint that something might be trying to communicate. On August 15, 1977, astronomer Jerry Ayman was reviewing data from the Big Ear Radio Telescope at Ohio State University when he noticed something extraordinary. A burst of radio energy at exactly the frequency predicted for intentional extraterrestrial communication. The signal was so striking that Ayman circled it on the printout and wrote, "Wow," in the margin. The signal lasted 72 seconds, the maximum duration the telescope could observe any point in the sky as Earth rotated. It was 30 times louder than the background noise. It came from the direction of the constellation Sagittarius. And it never repeated despite decades of subsequent observation. What was the wow signal? Natural explanations have been proposed, but none is fully satisfying. Comets, satellites, and terrestrial interference have all been suggested, and all have problems. The signal remains unexplained after nearly 50 years. In the context of the zoo hypothesis, the wow signal might represent something like a momentary breach in the observation protocol. A signal that was never supposed to be detected, quickly suppressed, never repeated. An error in the process of hiding that briefly revealed the presence of observers. The Tabby's star phenomenon presents another puzzling observation. KIC 8,462,852, nicknamed Tabby's star after astronomer Tabitha Boyagian, who led the study of its strange behavior, dims unpredictably and dramatically in ways that no natural explanation fully accounts for. At times, the star dims by up to 22%, far more than any known planet or dust cloud should produce. Some scientists proposed that the dimming might be caused by a megastructure, a Dyson swarm of solar collectors orbiting the star and occasionally blocking its light. This explanation was largely dismissed as improbable, but it was seriously considered by professional astronomers because the observations were genuinely anomalous. If alien megastructures exist anywhere in our galaxy, Tabby's star is one of the most plausible candidates. The interstellar visitor Oumuamua, which we discussed earlier, adds another data point. The object's strange acceleration, unusual shape, and interstellar origin make it unlike any natural object previously observed. Avi Loeb's suggestion that it might be an alien probe was controversial, but came from one of the world's leading astronomers. Even if Oumuamua was natural, its strangeness illustrates how limited our ability to distinguish natural from artificial phenomena might be. Closer to Earth, the unexplained aerial phenomena captured by military sensors present ongoing puzzles. The gimbal video, the Go Fast video, and the Tic Tac incident all show objects performing maneuvers that appear impossible for any known technology. The United States government has officially acknowledged that these objects are real, not sensor artifacts, and that they remain unexplained. None of this evidence proves the zoo hypothesis. Each observation might have natural or conventional explanations we simply haven't discovered yet, but the accumulation of anomalies creates space for the hypothesis to be true. We cannot prove we are being watched, but we also cannot prove we are not. What they found next would prove even more disturbing about how our own behavior might affect the observer's decisions. If we are being observed and evaluated, our behavior might determine our fate in ways we cannot perceive. The choices humanity makes, collectively and individually, might be the data points that decide whether we are contacted, protected, ignored, or eliminated. Consider how humanity might appear to an objective observer. In less than a century, we have developed technologies capable of destroying our own civilization. We have created nuclear arsenals sufficient to render the planet uninhabitable. We are changing our climate in ways that threaten billions of lives. We have driven countless species to extinction and continue to do so at accelerating rates. At the same time, we have also demonstrated remarkable capabilities. We have eradicated diseases that killed millions. We have lifted billions out of extreme poverty. We have developed arts and sciences that reveal deep truths about the universe. We have begun to expand beyond our planet, reaching for the stars that our ancestors could only wonder about. Which pattern matters more to the observers? Do they see a dangerous species that should be quarantined indefinitely, perhaps eliminated before it becomes a threat to others? Or do they see a promising species struggling through a difficult adolescence, worthy of patience and eventual contact? The zoo hypothesis suggests that our future might depend on how we answer this question through our actions. Every war we fight, every treaty we sign, every technology we develop, every choice we make about the environment and each other might be entered into some cosmic ledger, contributing to an evaluation we cannot see. This perspective transforms ordinary human activities into acts of potential cosmic significance. The climate negotiations of world governments might be observed by beings who have seen countless species fail similar tests. The development of artificial intelligence might be watched by entities who know exactly how such technologies typically evolve. Our efforts to prevent nuclear war might be evaluated against criteria we cannot imagine. Perhaps more disturbingly, the evaluation might already be complete. The observers might have already decided what to do with humanity. They might be waiting for some predetermined moment to act, or they might be simply watching what happens with no intention of intervening regardless of our behavior. We might be performing for an audience that has already left the theater. The uncertainty is part of what makes the zoo hypothesis so psychologically difficult. We cannot know if we are being watched. We cannot know what the watchers want. We cannot know if our choices matter or are irrelevant. We are left to act without knowledge, to choose without understanding, to live without knowing whether any of it matters to anyone beyond ourselves. But here's where the mystery deepens into whether we could ever escape the zoo. If Earth is a nature preserve managed by advanced civilizations, is there any way out? Can the exhibit become the visitor? Can the observed become the observer? The history of human interaction with isolated populations offers some guidance, though the analogies are imperfect. When isolated tribes in the Amazon or Papua New Guinea have been contacted by the outside world, the results have been devastating. Disease has wiped out large portions of their populations. Their cultures have been disrupted or destroyed. Their ways of life have been replaced by dependency on technologies and systems they do not understand. If the zoo hypothesis is correct, the observers might be keeping us isolated precisely to prevent such outcomes. They might know from experience that contact between vastly different levels of civilization is almost always harmful to the less developed party. The zoo walls might be for our protection, but protection can also be a cage. An animal in a sanctuary is still an animal that cannot leave. A species protected from contact is also a species denied access to knowledge and opportunity that might transform its existence. If we are being protected, we are also being constrained. Some formulations of the zoo hypothesis suggest that the constraints are temporary. Species that demonstrate sufficient development, whether technological, ethical, or some combination, might eventually be permitted to leave the zoo and join the broader community. The observation period might be a probationary phase that eventually ends. If this is the case, humanity might be able to accelerate our graduation by demonstrating the qualities the observers value. If they want us to achieve interstellar travel, we should pursue space exploration aggressively. If they want us to develop sustainable civilizations, we should prioritize environmental protection. If they want us to demonstrate ethical maturity, we should work to reduce conflict and increase cooperation. The difficulty is that we don't know what criteria the observers might use. We might be failing tests we don't know we're taking, or passing tests on metrics we haven't considered. The path out of the zoo, if one exists, might require developments we cannot currently imagine. Alternatively, we might need to escape through detection rather than development. If the observation protocol requires the observers to remain hidden, breaking that concealment might change the dynamic. If we can prove we are being watched, the watchers might have no choice but to reveal themselves. This possibility suggests that the search for extraterrestrial intelligence is not merely scientifically interesting, but existentially important. SETI might be our best chance of triggering the end of observation and the beginning of contact. Every radio telescope scanning the sky, every algorithm searching for anomalous signals, every scientist studying unexplained phenomena might be contributing to humanity's liberation from cosmic quarantine. But escape might also have costs we cannot foresee. The isolated tribes who have contacted the modern world have often regretted it. They have lost more than they gained. They have been overwhelmed by forces they could not control. If we escape our zoo, we might find that the universe outside is far more dangerous than the protected space we left behind. The second section of our exploration ends here. We have examined the variations and extensions of the zoo hypothesis, from the planetary park concept to the simulation argument. We have considered the possible purposes of observation, from scientific research to entertainment to evaluation. We have explored what might trigger the end of observation and the beginning of contact. We have looked at historical figures who anticipated these ideas and evidence that might support them. We have confronted the possibility that our behavior is being evaluated and that our fate might depend on choices we are making right now. In the final section, we will ask the deepest questions the zoo hypothesis raises. We will consider what it means for human meaning and purpose if we are being observed. We will explore how we should live if the hypothesis might be true. And we will confront the ultimate question of whether we even want to know the truth about our situation in the cosmos. The watchers, if they exist, continue their observation. The silence of the universe continues to puzzle us, and somewhere out there, perhaps closer than we imagine, something may be deciding what happens next. The zoo hypothesis does more than challenge our assumptions about the cosmos. It challenges our assumptions about ourselves. If humanity exists under observation, If our world is a managed exhibit in some vast cosmic collection, then everything we believe about meaning, purpose, and significance must be reconsidered. The questions that arise are not merely scientific. They are philosophical, psychological, and perhaps spiritual in the deepest sense. For most of human history, we have constructed meaning through narratives that place us at the center of existence. Religious traditions across cultures have described humanity as the special creation of divine beings, made in their image, given dominion over the earth, central to the purposes of the universe. Even secular narratives tend to assume that human consciousness represents something uniquely important, a pinnacle of evolution, a light of awareness in an otherwise dark and mindless cosmos. The zoo hypothesis disrupts these narratives profoundly. If we are exhibits in a cosmic zoo, we are not at the center of anything. We are not the pinnacle of evolution, but merely one experiment among countless others. We are not the purpose of the universe, but incidental to purposes we cannot comprehend. Our entire history, every achievement and failure, every triumph and tragedy, might be no more significant to our observers than the life cycle of a paramecium is to a microbiologist. This realization produces what philosophers call cosmic horror, a terror that comes not from any specific threat, but from the recognition of our own insignificance. H.P. Lovecraft built an entire literary tradition around this concept, creating fictional universes in which humanity is surrounded by entities so vast and alien that merely perceiving them causes madness. The zoo hypothesis suggests that Lovecraft's fictional horror might be closer to reality than his readers imagined. But cosmic horror is not the only possible response. The same situation that inspires terror can also inspire wonder, humility, and even a strange form of comfort. If we are being observed, at least we are not alone. If we are exhibits, at least we are interesting enough to watch. If vast intelligences have chosen to preserve Earth and its inhabitants, perhaps there is value in our existence that we ourselves cannot perceive. What they found next would prove even more disturbing about how the hypothesis affects our understanding of human achievement. Consider the greatest accomplishments of human civilization through the lens of the zoo hypothesis. The pyramids of Egypt, standing for over 4,000 years. The works of Shakespeare, still performed around the world. The discovery of general relativity and quantum mechanics, revealing the deep structure of reality. The moon landing, humanity's first step onto another world. How do these achievements appear to observers who might have witnessed the rise and fall of a million civilizations? To beings who might have mastered physics beyond our comprehension, who might have created wonders that make our greatest works look like cave paintings? The honest answer is that we don't know. Perhaps our achievements are genuinely impressive, remarkable for a species so young. Perhaps the observers watch our struggles the way we watch a child learning to walk, charmed by the effort even when the results are clumsy. Perhaps they have learned to appreciate primitive art and science the way human connoisseurs appreciate folk art or outsider art. Or perhaps our achievements are utterly insignificant, barely registering as noteworthy in the context of galactic history. Perhaps our greatest scientific discoveries were made by countless other species billions of years before we existed. Perhaps our most beautiful art is crude by the standards of beings with senses and cognitive capabilities we cannot imagine. Perhaps everything we have ever done amounts to nothing more than mildly interesting data for some research project we will never understand. This uncertainty cuts both ways. It might diminish our accomplishments by placing them in a context where they seem trivial, but it might also elevate them by suggesting they have value to observers beyond ourselves. If advanced civilizations find Earth worth watching, something about us must be interesting. We might not understand what that something is, but its existence is implied by the hypothesis itself. The zoo hypothesis also transforms our understanding of human suffering. If observers have watched every war, every plague, every genocide in human history without intervening, what does this mean for the significance of that suffering? One interpretation is deeply pessimistic. Our suffering might be meaningless to the observers, no more significant than the death of cells in a petri dish. They might watch atrocities with the detached interest of scientists observing experimental subjects, recording data without emotional engagement, indifferent to the experience of those they study. Another interpretation is more complex. Perhaps our suffering matters to the observers, but they have reasons for not intervening that we cannot understand. Perhaps they have learned that intervention causes greater harm than non-intervention. Perhaps they believe that species must solve their own problems to develop properly. Perhaps there is a cosmic ethics we cannot perceive that justifies apparent inaction. A third interpretation offers something like hope. Perhaps our suffering is noted and mourned by beings who wish they could help, but are constrained by rules or circumstances beyond their control. Perhaps the zoo is temporary, and our eventual liberation will bring an end to unnecessary suffering. Perhaps the observers are waiting for us to reach a point where they can intervene without causing harm. We cannot know which interpretation is correct, but the zoo hypothesis forces us to consider these possibilities seriously. It demands that we think about meaning and suffering in a cosmic context, not merely a human one. But here's where the mystery deepens into how we should live if the hypothesis might be true. The possibility that we are being observed raises practical questions about human behavior. If our actions are being recorded and evaluated, does this change what we should do? If the observers might eventually make contact or render judgment, should we behave differently than we would otherwise? One response is that the hypothesis changes nothing. We should live according to our own values regardless of whether anyone is watching. Ethical behavior is ethical behavior whether or not it is observed. If we believe that kindness, honesty, justice, and compassion are good, we should practice them for their own sake, not because observers might be keeping score. This response has philosophical integrity, but it may be psychologically incomplete. Human beings are social creatures whose behavior is profoundly influenced by observation. We act differently when we know we are being watched. The possibility of cosmic observation might, for some people, provide motivation for ethical behavior that they would not otherwise have. Another response is that the hypothesis should make us more careful about our collective behavior. If humanity is being evaluated, we might all have a stake in how our species presents itself. The choices made by governments and corporations and institutions might affect not just our own lives, but our cosmic reputation. We might want to ensure that the record of human civilization is one we can be proud of, not because the observers care about our pride, but because we care about who we are. This response suggests a form of cosmic responsibility. We might be the representatives of Earth life in some vast interstellar community. The impressions we create might affect how Earth is treated for millennia to come. Our current struggles with war, inequality, and environmental destruction might be determining our species' future in ways we cannot perceive. A third response is that the hypothesis should inspire us to reach beyond our current limitations. If we are in a zoo, we should try to escape. If we are being tested, we should try to pass. If advancement is possible, we should pursue it with urgency. This might mean accelerating our development of space travel, our search for extraterrestrial intelligence, our efforts to solve existential risks, our work to become a species worthy of galactic membership. Each of these responses has merit. Each reflects genuine values that humans hold. The zoo hypothesis does not tell us how to live, but it expands the context within which we must make our choices. What they found next would prove even more disturbing about the psychological impact of believing the hypothesis. The belief that one is being watched can have profound psychological effects. Surveillance anxiety is a recognized phenomenon in human society, where awareness of observation changes behavior and creates stress. The zoo hypothesis extends this concept to its cosmic maximum. If the hypothesis is true, there is no escape from observation, no private space, no moment unrecorded. How would widespread belief in the zoo hypothesis affect human psychology? The answer might depend on how the hypothesis is framed and understood. If the observers are perceived as benevolent, like protective parents or wise guardians, belief in the hypothesis might be comforting. Knowing that someone powerful is watching over us might reduce anxiety about existential risks. Knowing that our actions matter to beings beyond ourselves might provide meaning and motivation. The hypothesis might function psychologically like belief in a protective deity, offering security and significance. If the observers are perceived as indifferent, like scientists studying bacteria, belief in the hypothesis might be alienating. Knowing that our suffering doesn't matter, that our achievements are trivial, that we are specimens rather than persons, might undermine meaning and motivation. The hypothesis might produce despair, nihilism, or withdrawal from engagement with life. If the observers are perceived as potentially threatening, like hunters or predators, belief in the hypothesis might generate paranoia. Every unexplained phenomenon might be interpreted as evidence of hostile surveillance. Every difficulty might be seen as deliberate interference. The hypothesis might produce anxiety disorders, conspiracy thinking, or social breakdown. The psychological impact would also depend on whether the hypothesis could be confirmed or refuted. Permanent uncertainty is psychologically demanding. Humans generally prefer to know the truth, even when the truth is unpleasant. Living indefinitely with the possibility that we might be in a zoo, unable to confirm or deny it, might be more stressful than any definite answer. This uncertainty already exists, of course. The zoo hypothesis is already a logical possibility that cannot be ruled out. But most people do not think about it, do not take it seriously, do not feel its weight. Widespread awareness and belief might change this, transforming an abstract possibility into a felt reality. But here's where the mystery deepens into whether we would even want to know the truth. Suppose we could discover definitively whether the zoo hypothesis is true. Suppose some observation or communication could settle the question once and for all. Would we want to know? The question is not as simple as it seems. Truth is generally valued, but some truths might be harmful. Some knowledge might be more than we can bear. The answer to whether we are in a zoo might be one of these dangerous truths. Consider what happens if we discover the hypothesis is true. We learn that our entire existence has been observed by beings we cannot comprehend. We learn that our apparent freedom exists within boundaries set by others. We learn that our meaning and significance depend on purposes we do not understand and cannot influence. This knowledge might shatter human civilization. Religious frameworks would need to be fundamentally reimagined. Scientific confidence in our understanding of reality would be undermined. The psychological foundations on which people build their lives might collapse. Some might adjust and find new sources of meaning. Others might not. The history of human contact with isolated populations suggests the dangers. When indigenous peoples have encountered vastly more powerful civilizations, the results have often been catastrophic. Not just disease and conquest, but psychological devastation, loss of meaning, loss of identity, loss of the will to continue. We might be more resilient than isolated tribes. We have science fiction that has prepared us imaginatively for the possibility of alien contact. We have philosophical frameworks that can accommodate cosmic insignificance. But we also might not be prepared at all. The gap between imagination and reality is vast. Reading about aliens is very different from learning that they have been watching your every move since before you were born. Consider alternatively what happens if we discover the hypothesis is false. We learn that we are truly alone, or at least unobserved. We learn that no one is watching, no one is protecting us, no one has any interest in our survival or development. We learn that everything we do matters only to ourselves. This knowledge might also be devastating, though in different ways. The universe would feel emptier, colder, more indifferent. The hope of eventual contact, of joining a cosmic community, of meaning beyond ourselves would be extinguished. We would be alone with ourselves forever, responsible for our own fate with no possibility of rescue or assistance. Some people might find this liberating. Without observers, we are truly free. Without cosmic significance, we can create our own meaning. Without expectations from above, we can determine our own values and purposes. The absurdist philosophers argued that meaning could be created even in a meaningless universe. They might be right, but many people might find the loneliness unbearable. Humans are social creatures who need to feel connected to something beyond themselves. The cosmos without observers might feel like solitary confinement on an infinite scale. The silence of the universe might be not just a scientific puzzle, but an existential wound. Perhaps the best outcome is continued uncertainty. Perhaps we should search for the truth without ever finding it, maintaining hope and wonder while avoiding the potential devastation of definitive answers. Perhaps the question is more valuable than any answer could be. What they found next would prove even more disturbing about the implications for humanity's future. The zoo hypothesis has profound implications for humanity's long-term future. If we are being observed and potentially managed, our options might be more constrained than we realize. If we are being tested, our future might depend on choices we are making right now. If we are being protected, that protection might not last forever. Consider the possibility that the observers have plans for humanity that we cannot perceive. They might be guiding our development towards some purpose of their own. They might be waiting for us to reach some threshold before acting. They might be preparing to intervene in ways that will transform our existence. In science fiction, first contact is often portrayed as a pivotal moment, a turning point after which everything changes. The zoo hypothesis suggests this moment might come not when we detect the observers, but when they choose to reveal themselves. We might have no control over when this happens. We might be waiting for a decision made by others, a decision that could come tomorrow, or might never come at all. What would happen if the observers revealed themselves? The initial shock would be enormous, perhaps the greatest shock in human history. But after the shock, what? If the observers are benevolent and wish to share their knowledge, we might experience the most rapid advancement in human history. Technologies that would take us centuries to develop might be given to us immediately. Medical knowledge might end disease and extend life indefinitely. Understanding of physics might provide unlimited energy and the ability to travel between stars. The problems that have plagued humanity for millennia might be solved overnight. But this scenario has dark possibilities as well. Dependence on the observers might become total. Human agency and initiative might atrophy. Our cultures and identities might be overwhelmed by alien influence. We might become not partners but pets, comfortable and well-fed, but no longer truly independent. If the observers are indifferent and merely acknowledge our existence before returning to their own concerns, we might be left to make our own way as before. The knowledge that others exist would transform our perspective, but our practical situation might not change. We would still face the same challenges, still need to solve our own problems, still bear responsibility for our own future. If the observers are hostile, or if we have failed whatever test they were applying, the results might be catastrophic. Humanity might be eliminated as a threat. Earth might be sterilized to make way for other purposes. Our entire existence might end not through our own failures, but through the decision of beings whose power we cannot resist. The zoo hypothesis thus introduces a new category of existential risk. We typically worry about threats we might pose to ourselves: nuclear war, pandemic, climate change, artificial intelligence. But if the hypothesis is true, the greatest threat to humanity might come from outside, from observers who might at any moment decide that the experiment is over. But here's where the mystery deepens into what the hypothesis reveals about the nature of reality itself. At the deepest level, the zoo hypothesis forces us to question what reality actually is. If our world is managed and observed by beings beyond our comprehension, can we trust our perceptions of reality? Can we trust our science? Can we trust anything? Consider the possibility that the observers have shaped our reality in ways we cannot detect. They might have influenced the course of evolution, steering life toward outcomes they desired. They might have seeded Earth with the building blocks of life in the first place. They might have created the conditions that make our planet habitable, adjusting cosmic parameters to produce a suitable environment. This possibility resonates with the fine-tuning argument in physics. The constants of nature, the strength of gravity, the charge of the electron, the mass of the proton, appear to be precisely calibrated to allow the existence of life. If any of these constants were slightly different, stars would not form, chemistry would not work, life would be impossible. The fine-tuning seems improbable, as if someone had adjusted the dials to make life possible. Physicists have proposed various explanations for fine-tuning. The multiverse hypothesis suggests that all possible values of the constants exist in different universes, and we naturally find ourselves in one compatible with our existence. The anthropic principle suggests that we can only observe constants that permit observers to exist. But the zoo hypothesis suggests another possibility. The constants might be fine-tuned because someone fine-tuned them. Reality might be designed, and we might be living in the result. If reality is designed, our science might be discovering not fundamental truths, but parameters chosen by designers. The laws of physics might be not eternal necessities, but local rules, applicable within our designed space, but not universal. Our deepest understanding of the cosmos might be understanding of an artifact rather than of fundamental reality. This possibility is both disturbing and humbling. It suggests that even our most profound insights might be shallow, that even our greatest theories might be descriptions of a constructed surface rather than ultimate depth. It suggests that reality, as we know it, might be a subset of a larger reality we cannot access. At the same time, the hypothesis might not change anything about how we do science. Whether reality is designed or fundamental, the patterns we observe are still the patterns we observe. The predictions that work still work. The technologies we build still function. Science remains our best tool for understanding the world we experience, even if that world is an exhibit in a cosmic zoo. What they found next would prove even more disturbing about the connections between the zoo hypothesis and human spirituality. Humans have always sensed that they were being watched. Throughout history, across virtually every culture, people have believed in beings who observe human affairs from beyond the visible world. Gods, angels, spirits, ancestors, these entities were thought to watch over humanity, judging actions, intervening in events, shaping destinies. The zoo hypothesis provides a naturalistic framework for these intuitions. If advanced beings have been observing Earth for thousands or millions of years, the sense of being watched might not be mere superstition. It might be accurate perception of something real, interpreted through the cultural frameworks available at the time. Ancient peoples who described gods descending from the sky might have been describing real encounters with real beings. Prophets who claimed to receive messages from heaven might have been in contact with actual non-human intelligences. Miracles and supernatural events might have been technologies so advanced they appeared magical to their witnesses. This interpretation is sometimes called the ancient astronaut hypothesis, and it is usually dismissed by mainstream scholars. The evidence for ancient alien contact is speculative at best, and the interpretation often reflects modern assumptions projected onto ancient texts. Nevertheless, the pattern of human belief in watching beings is striking. It appears across cultures that had no contact with each other, in times and places separated by thousands of miles and thousands of years. Perhaps this pattern reflects something universal about human psychology, a tendency to anthropomorphize nature and imagine invisible watchers. Perhaps we are wired by evolution to assume that agency exists behind events, a useful bias for social species that must navigate complex relationships. But perhaps the pattern reflects something else. Perhaps humans have always sensed the observation because observation has always been occurring. Perhaps religious experience, in its many forms, represents genuine contact with the reality behind the zoo. Perhaps the divine, as understood by human religions, is the best approximation available to minds limited by their position inside the exhibit. This possibility does not validate any particular religious tradition. If the observers exist, they are probably not the gods described by any human religion, or at least not exactly as described. But it suggests that religious intuitions might point towards something real, even if the interpretations are imperfect. The zoo hypothesis thus occupies strange territory between science and spirituality. It is a scientific hypothesis in the sense that it attempts to explain observable phenomena through naturalistic causes, but its implications overlap with religious claims about cosmic purpose, observation by higher beings, and the significance of human existence. Some might find this overlap disturbing, a contamination of science by religion. Others might find it reassuring, a suggestion that science and spirituality point toward the same truths from different directions. Still others might find it irrelevant, noting that similarity of claims does not imply similarity of reality. The observers of the zoo hypothesis, if they exist, might have nothing to do with the divine as traditionally understood. But here's where the mystery deepens into the ultimate question of what we should do. We have explored the zoo hypothesis from many angles. We have considered its scientific basis, its logical structure, its historical antecedents, its evidence, its implications for meaning and purpose. We have asked whether it is true, whether we could know if it were true, whether we would want to know. Now we must ask the most practical question of all: what should we do? If the zoo hypothesis is true, what actions are appropriate? If it might be true, how should the possibility affect our choices? One answer is that we should continue searching for the truth. The question of whether we are alone in the universe is perhaps the most profound question humanity can ask. We should fund SETI research, build better telescopes, develop better detection methods, search for evidence of observation with every tool at our disposal. If the observers exist, we should try to find them. If they are hiding, we should try to discover their presence. The truth is worth pursuing regardless of what it might be. Another answer is that we should behave as if we are being evaluated. If there is any chance that our actions are being judged, any possibility that our behavior might affect our cosmic future, we should try to be the best species we can be. We should pursue peace, justice, sustainability, and cooperation, not merely because these are good in themselves, but because they might matter to observers whose good opinion we need. We should imagine ourselves as representatives of Earth life, ambassadors to the cosmos, and try to make a good impression. A third answer is that we should focus on our own development regardless of observation. Whether or not anyone is watching, we should pursue knowledge, wisdom, and capability. We should try to become a species that can solve its own problems, that can survive existential risks, that can eventually spread beyond Earth and join whatever community might exist among the stars. We should become worthy of membership in the Galactic Club, even if we don't know whether such a club exists. A fourth answer is that we should embrace the uncertainty. We may never know whether the zoo hypothesis is true. We may never receive the answers we seek. In that case, we should learn to live with not knowing. We should find meaning in the search itself, in the questions we ask, in the wonder we feel when we contemplate the cosmos. The mystery might be permanent, and that permanence might be okay. Perhaps all of these answers are correct simultaneously. Perhaps the appropriate response to the zoo hypothesis is a combination of searching for truth, behaving ethically, pursuing development, and embracing uncertainty. Perhaps we should do all of these things together, recognizing that each captures part of what the hypothesis demands of us. What they found next would prove even more disturbing about the nature of the question itself. In the end, the zoo hypothesis might reveal more about us than about the cosmos. The fact that we can formulate such a hypothesis, that we can take it seriously, that we can explore its implications with rigor and imagination, says something profound about human consciousness. We are the species that asks why. We are the beings who wonder about our own existence, who seek meaning beyond survival, who imagine possibilities beyond what we can observe. We look up at the stars and ask if anyone is looking back. We contemplate our own insignificance and search for significance anyway. This capacity for cosmic wonder is itself remarkable. Most life on Earth is unaware of the universe beyond immediate experience. Only humans, as far as we know, contemplate questions about alien civilizations and cosmic purpose. Only humans formulate hypotheses about being observed by superior beings. Only humans torture themselves with questions that might have no answers. Perhaps this capacity is what makes us interesting to any observers who might exist. Perhaps it is not our technology or our art or our science that draws their attention, but our irrepressible need to understand. We might be the species that asks the questions the observers find most fascinating. We might be valuable not for what we know, but for what we want to know. Or perhaps our capacity for wonder is common in the universe, shared by countless species on countless worlds, unremarkable to beings who have seen it develop billions of times before. Perhaps our questions are not special at all, merely the predictable output of minds reaching a certain level of complexity. Perhaps we are interesting only in the way that any data point is interesting, one more example of patterns that repeat across cosmic history. We cannot know which is true. We cannot know whether our wondering matters to anyone beyond ourselves. But the wondering happens regardless. It is part of who we are. It is perhaps the most human thing about us. The zoo hypothesis, in the final analysis, is an expression of this wondering. It is a question we ask because we cannot help asking. It is an exploration of possibility that we undertake because exploration is in our nature. Whether the hypothesis is true or false, the asking of it is worthwhile. The contemplation of it expands our sense of what might be real. The exploration of it stretches our minds toward horizons we would not otherwise perceive. Now we can see how all these pieces fit together into a portrait of humanity's cosmic situation. We have considered the Fermi paradox and the silence that haunts our search for extraterrestrial intelligence. We have examined the zoo hypothesis in its original formulation and its many variations. We have explored the evidence that might support or refute it, the purposes that might motivate cosmic observation, the implications for human meaning and behavior. The picture that emerges is one of profound uncertainty. We do not know if we are being watched. We do not know if intelligence beyond our own exists anywhere in the universe. We do not know if our choices matter to anyone beyond ourselves. We do not know what our future holds. But this uncertainty is not meaningless. It defines our situation. It shapes the questions we ask and the way we live. It creates the space within which human meaning is constructed. If we knew for certain that we were alone, meaning would have to be created entirely from within. If we knew for certain that we were observed, meaning might flow from our relationship with the observers. In our actual situation of uncertainty, meaning exists in the tension between these possibilities, in the search for truth that might never be completed, in the hope that transcends knowledge. The universe is vast and ancient and strange. 2 trillion galaxies contain wonders we have not yet imagined. Billions of years stretch behind us, and perhaps infinitely more stretch ahead. In this enormity, one small planet orbits one ordinary star, carrying beings who have existed for an eye blink of cosmic time, but who have learned to ask questions that span eternity. Are we in a zoo? Are we being watched? Do our choices matter to observers beyond ourselves? Perhaps. Perhaps not. We may never know, but we can choose how to live with the question. We can choose to search for truth with humility and persistence. We can choose to behave as if our actions matter, whether or not anyone is watching. We can choose to develop our capabilities and expand our wisdom, preparing for whatever future awaits. We can choose to embrace the mystery rather than be paralyzed by it. The observers, if they exist, might be waiting to see what we choose. The universe, whether empty or full, will continue regardless. And humanity, poised between insignificance and possibility, will write the next chapter of its story one decision at a time. We are the species that wonders. We are the beings who ask. And the asking itself might be the most important thing we do. The stars continue to shine in their billions. The silence continues to puzzle us. The question of whether we are alone continues to haunt our nights. And somewhere out there, perhaps, something is still watching. If so, may it be impressed by what it sees. May it find in humanity something worth preserving, worth contacting, worth welcoming into whatever community might exist beyond the walls of our cosmic exhibit. And if no one is watching, may we find in ourselves the strength to matter anyway. May we build meaning from nothing, significance from silence, purpose from the pure fact of our existence. Either way, we are here, we are conscious, we are wondering, and that, perhaps, is miracle enough. The zoo might be our prison or our nursery or our testing ground or our home. We might be exhibits or experiments or entertainment or something we cannot name. The truth might be knowable or forever hidden, but we are the beings who ask the question. We are the minds that contemplate the mystery. We are the consciousness that looks up at the sky and wonders what looks back. Whatever we are remarkable, and the story is not over yet.